Hello and welcome to my channel. I am msin and please, if you are new here, kindly subscribe to my channel, and if you have been watching my videos and if not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this video, we are given that y equal to sine of m times the inverse sine of x. We have to prove that into bracket 1 minus x squared times the squared y and x squared minus x dy dx plus m y squared equal to 0. Very simple as that. So here, how do we go about this question? But before we start, please like for others also to see that the video is very good, so that whenever they find the video on YouTube, they will also watch it. Subscribe to for us to build the mathematics community. Now let's go straight to the question. Now, before I do that, thanks to Ebenezer from the University of Lagos, Ghana, for sending me this question. If I take y to be equal to sine of t, that is, it implies that t equal to m times the inverse sine of x. That is, if we take t to be equal to the inner function, then we have y equal to sine of t. And here, the derivative of y with respect to t is equal to cosine t. That will give us cosine of m times the inverse sine of x as the derivative of y with respect to t. Now here, the derivative of t with respect to x is equal to m times the derivative of sine inverse of x with respect to x. And that will give us m times 1 divided by square root of 1 minus x squared. And that is m divided by square root of 1 minus x squared as dt on dx. Remember that here, the inverse sine function, its derivative is a standard derivative. I have a video on that, so check the description for my video on derivative of the inverse sine function, and you get to know why we have this. So if you multiply this by that, you get this. Now, the derivative of y with respect to x will be given by dt on dx times dy on dt. So dt on dx is m divided by square root of 1 minus x squared times cosine of m times the inverse sine of x. That will give us m times cosine of m times the inverse sine of x, all divided by square root of 1 minus x squared equal to dy on dx. Wow. Now, what are we supposed to do again? We have to prove that this is equal to that. So we've not reached anywhere. Now let's continue. To continue this one, what we have to do is that here you can use the quotient rule, or you can multiply this by that, and then we will just differentiate it implicitly. Okay, so here this contains only x, so let's use the quotient rule. So for the quotient rule, we are going to take the squared y on the x squared equal to m times m is a constant. So we have dx of cosine of m times the inverse sine of x, all divided by square root of 1 minus x squared. So here we have m times, we are going to differentiate the inner function here. So I'm going to do it here. Let's assume that we have a equal to cosine of m times the inverse sine of x. Now if we take, let's say u equal to m times the inverse sine of x, the derivative of u with respect to x is what we have done here. This one, yes. that is dt on dx. The same thing. This is what we've done here. So we follow the same thing to do this. Assuming let's use t here again. T equal to this. We take dt on dx. So it will give us this m divided by square root of 1 minus x squared. Then this implies that we have a equal to cosine of t, and that's the a on dt equal to negative sine of t, and that will be minus sine of m times the inverse sine of x as our dA on dt. Now, dA on dx will be equal to dt on dx, m divided by square root of 1 minus x squared times dA dt. Sorry. Yeah, dA dt. That is minus sine of m times the inverse sine of x. And that will give us minus m sine of m times the inverse sine of x, all divided by square root of 1 minus x squared as dA on dx. So if we differentiate what is at the top, this is what we are going to get. So you have to keep it in mind. Now, once we have this, we are going to have it as minus m sine of m times the inverse sine of x, all divided by square root of 1 minus x squared times square root of 1 minus x squared. That is the product rule. Minus, I think I can clean this portion. That's a negative sign. Minus cosine of m, the inverse sine of x, times, we are going to differentiate this one. So let me bring this all divided by square root of 1 minus x squared all squared. So how do we differentiate this and put it here? Have we done that one somewhere? No, we haven't done that one. So let's differentiate this, because we first differentiate the top and multiply it. We differentiate the numerator, multiply it by the denominator. So this is the numerator. We are going to differentiate the denominator. So that one, let's say we have Q equal to square root of 1 minus x squared. We have Q to be equal to 1 minus x squared all to the power half. We have Q equal to, check the description for my video on how to differentiate using the chain rule, and you get to understand it. But for the sake of time, I'm doing it more faster. So you bring half in front, you differentiate the inner function times the original function, but you subtract 1 from the power. That will give us minus x times all to the power negative 1 out of 2. This is about minus x divided by, if our negative comes down, become positive. Wow. So we multiply here by minus x divided by 1 minus x squared to the power half. Wow. Very, very simple as that. So how do we simplify this? And here is d²y on dx squared. Now let's clean some part of the board so that we can get the board. we will use our dy on dx. So dy on dx, let's put it somewhere here. So we have our dy on dx is equal to m cosine of m inverse sine of x, all divided by square root of 1 minus x squared. So let's put it 1 here and then clean the rest so that we can have the whole and right. Now, what can we do here? Here we have this, so let's simplify. Here, this one will cancel this. And we are going to have the squared y on x squared to be equal to I'm multiplying 2 by m. I'm multiplying 2 by m. So m times m will give me negative m squared sine of m times the inverse sine of x plus x times cosine of m times the inverse sine of x, all divided by 1 minus x squared to the power half. We have all divided by 1 minus x squared. For here, the square will cancel the square root. Now, let's look at this. Okay, this m2 will multiply this, so we have m here. Correct. We are multiplying 2 by the m, so m will multiply this, and m will multiply this. And here you see that negative will cancel negative. Here, this will multiply what is at the top. Remember, it is not multiplying this, the down one. Let me put it in brackets. Okay, so we have mx cosine of this, so we can do this one. We can do it as x and then m. Very simple as that. And then look at what this represents. It represents dy on dx. So let's put dy on dx there. By first doing cross multiply, that's multiplying this by that. So we have 1 minus x squared, the squared y on the x squared equal to minus m squared times sine of m. We have, okay, that one too can be substituted. Look at this. This is equal to y. So we put it there straight, y plus x dy on dx. And we are almost done. Yeah, that's very simple. We are doing the substitution. Oh, here we have 1 minus x squared here. We are done. If we look at this, it is y. If we look at this, it is dy dx. And we multiply this one by that to get this. So we just bring everything here to get 1 minus x squared, the squared y on the x squared, minus x dy on dx plus my squared equal to 0. And that is to be shown. Thank you for watching, and please subscribe to my channel. Please leave your comment, whether a good comment or a bad comment, so that the channel can be built, so that I can build the channel and also get more subscribers. Bye bye.